Graph theory, page 1. Planning efficient routes is essential for business and industry, with applications as varied as product distribution, laying new fiber optic lines for broadband internet, and suggesting new friends within social network websites. Each of these problems can be tackled using graph theory. So although this field of mathematics started about 300 years ago as a look into a mathematical puzzle, and I'm just going to refer you to this bridge problem over here that Euler popularized there, and he actually invented the idea of graph theory by trying to solve it, trying to invent some sort of mathematics to solve this. Graph theory has exploded in importance in the last century due to the growing complexity of business and a global economy, and because we have computers to do the heavy lifting. So we have a lot of vocabulary that we need to look into. So a graph consists of a finite set of points called vertices and line segments called edges. A vertex will be represented by a dot. A vertex could represent an intersection of streets, a landmass like Peoria and East Peoria, or a general location like work or school. Vertices are often not always connected by edges. Notice in the graph at the right that the vertices only occur when a point is explicitly placed, not whenever two edges cross. You'll need to change your thinking from the geometry you learned in high school. So remember, in geometry, we're saying the intersection of two lines is a point. Well, there's no vertex right there. I just drew an arrow there. There is no vertex there. It would be like, think about an overpass, a freeway overpass. The freeway and the street passing underneath the freeway would appear to cross on the graph, but it's not possible to change from the street below to the freeway at that point. Of course, unless there was some loud yelling of yeehaw and, going off the freeway. I don't know. In terms of the graph, there is no intersection for most people. Therefore, no vertex would be placed. So edges, as we said before, connect pairs of vertices. An edge can represent a physical connection between locations like a street or a pipeline, or simply that a route connecting the two locations exists, like an airline flight. A loop is a special type of edge that connects a vertex to itself.